Alright, so I believe that I'm recording. Let's take a look at these daily math problems that we had on Monday. As promised, I gave you have you identify the quadratic formula. Whoa, what happened there? Huh. And I was moving things around. I must have bumped something. So we have this quadratic equation, ax squared plus bx plus c. We refer to that equation written in standard form when it's in descending order, when it's equal to 0, and you can identify a, b, and c given a specific problem, and then you can use the formula to find the solutions. But you have to know that formula, and so here's 4 choices. Well, it's choice B, and I've memorized it. It starts out in the numerator the opposite of B. Well, this is not the opposite of B. This is not the opposite of B, and that's plus or minus b squared. So the opposite of b plus or minus the square root of b squared minus 4ac divided by 2a. So that's what we want to know. And if we're given a quadratic equation, this will always provide us the solution. So let's move on now to number 2. If we want, we can use that quadratic formula that we just identified in problem number 1. But it's probably easier, or at least a little bit faster, if we solve this by factoring using the x method. So you take the first term times the last term and place it at the top of your x. You place the x over the middle term. Now you're looking for 2 numbers that when multiplied together give you this top value of the x, but yet when added give you the bottom value of the x. So 4x and 5x do the trick that 4x times 5x is 20x squared and 4x plus 5x is 9x. With a leading coefficient of 1, we don't necessarily have to come in and fill in this table. See, we normally now go to a table to where you put the first term and the last term along one diagonal, and these 2 values that we found in the x go in the other diagonal. But every time that this leading coefficient is a 1, you're always going to get x times x right there. So that means that we're going to see x times x right here, and when we look here, we're always going to get the coefficient and the coefficient of the other. So most of the time students don't fill in the table when this is a leading coefficient of 1. Now you certainly can, but what you're always going to, every time this is 1, you're always going to get x here and here, and the 2 coefficients, you're always going to get those on the outside of that table. That's how I'm able to just skip the table and immediately go to my next equation in factored form. So now we have a theorem that says that if you have a product, if you're multiplying 2 numbers together and you get 0, then one of the factors has to be 0. Either this first number, x plus 4, represents 0, or this other number, x plus 5, it must represent 0. Well, this x plus 4 will equal 0 when x is negative 4, because a negative 4 plus a positive 4 cancel each other out and give us 0, and 0 times anything is 0. This is a one-step equation. If you subtract 5 from each side of this equation, you'll get that x is negative 5. And if you plug in negative 5 into this equation, in this first factor, you get negative 1 when you add these together. But over here, since negative 5 and positive 5 are opposites, and we're adding these opposite values, they cancel each other, they sum to 0, and 0 times anything is 0. So for number 2, using your x method, you have this. Now let's go ahead. Some people, I haven't looked at the papers yet, but I'm sure that some people may have used the quadratic formula. So let's do the same problem again, illustrating that we would get the same answer with the quadratic formula. So we identify a, b, and c. This is in standard form, that in descending order, and we identify A is the coefficient of our squared term. B is the coefficient of our x to the first of our linear term. And our constant, the one that doesn't have a variable with it, is C is equal to 20. So I identify A, B, and C. So I come in to use the quadratic formula, and I take the opposite of B. The opposite of positive 9 is negative 9, plus or minus B squared. Well, B squared, that's going to be 81, minus 4 times A times C. Now, I didn't have to put the 1 in necessarily, but as a visual aid I did, because 4 times 1 is just 4. So we have 4 times A times C, all divided by 2 times A. So let's see what we have here. We've got negative 9, plus or minus, and over here, let's figure out this number that's underneath the radical. Let's take 9 squared minus 4 times A times C. We get 1. Okay, 81 minus, this is 81 minus 80, which is the number 1. Well, and 2 times 1 is 2. I don't need a calculator to tell me that the square root of 1 is 1, because 1 times 1 is 1. So this splits into 2 equations. In one equation, we have negative 9 minus 1 divided by 2. And that numerator, that's negative 10, and negative 10 divided by a positive 2 is negative 5. Or we have this negative 9 plus 1. Negative 9 plus 1 is a negative 8, and negative 8 divided by 2 is negative 4. And these are the same two values, maybe in a different order, that we had last time. So by factoring, we got negative 4 and negative 5, and with the quadratic formula, we got negative 4 and negative 5 as the same answer. So you can do it either way, unless the directions specify that to do it factoring or to do it with the quadratic formula. Now, if we had tried here to factor it, we would see that we can't do it. If we do the x method, on the top of the x we've got 6x squared. But when we look at numbers that multiply together to give us 6, it's small enough that we can write them down over here. We've got 1 times 6 gives us 6, and 2 times 3 gives us 6. But when you add these together, 1 plus 6 is 7, and we're looking for 9. 2 plus 3 is 5, but we're looking for 9. There's no other factors to consider, so we can't factor this. But we can, no matter what, we can always apply the quadratic formula. So let's identify A, B, and C. And the quadratic formula is a fraction to where the first term of the numerator is the opposite of B. The opposite of positive 9 is a negative 9. Plus or minus the square root of, and underneath here, just for your information, it's called the discriminant. And it's B squared. So 9 squared minus 4 times A is 1, times C, and that's 6. All divided by 2 times 1. 9 squared is 81, and 81 minus 24, is that 57? What's 81 is 9 squared, right? Because if I go 9 squared minus 4 times 1, well, I didn't have to key that in because 4 times 1 is 4, times 6. So 81 minus 24, yeah, 57. Now 57 is a prime number, so I know that there's no perfect square that divides 57, and so I can't simplify this radical. In fact, if 57 is a prime number, I can't reduce it at all. So 2 times 1 is 2. So this is our final answer. I'm just going to leave this as our final answer. Now recognize that that's two answers, one with addition and one with subtraction. All right, problem number 4. Now, we can't apply the x method here because we have more than 3 terms. So, and you guys had told me on this that you prefer, when I was doing the factoring on the weekly, I factored by grouping, and students said, well, we didn't learn it originally like that, so we would prefer to keep consistent, and I agree with that statement, to be consistent with what you've learned before and how you've learned it, that use the same technique. You guys filled in this table. Now with the X method, you fill in the table along the diagonals, but with this you don't. You go straight across from left to right. So be very careful. Make sure that you're in descending order. We've got exponents 3, 2, 1, and the constant, and also make sure that you don't have, that you factor the greatest common factor. So with 1, 2, 4, and 8, although the 2, -4, -8 are all even numbers, the 1 is not, so I can't factor a greatest common factor from these 4 terms. So I have x to the 3rd power 2x squared, because I'm just moving straight across from left to right. When I fill in that row, I come down and move left to right along the next row with -4x minus 8. So it's important that you don't try to fill it in diagonally, because then that's going to create a challenge and mess your problem up for you. Alright, so let's look here and see what's common to each of these terms, and both of these terms are divisible by -4. And if we look vertically, we don't have a variable in each of these, but they are numbers, and both numbers are even, so both numbers are divisible by 2, and -4 times a +2 is -8. So far everything's working fine, and I have no contradictions at all. If I look horizontally across here, it might help me to put a coefficient of 1 in front of x cubed to recognize that they don't have any numbers in common, but however the variable x squared, we have a common factor of x squared in both terms. If we look vertically here, the 1 and -4, they just have a 1 in common, but the x to the 1st power, x to the 3rd power have a single factor of x in common. So we can now take these 4 terms and factor this into x squared minus 4 times x plus 2. And we can jump in and begin solving here, but I think it'll be easier on us to recognize that this x squared minus 4, that we can keep factoring it. The x squared minus 4 is x plus 2 times x minus 2. Now if you don't see that, how would you get it? Well, you could use the x method. Let's take this x squared minus 4, but we're going to have to put in a 0x there. We don't have any term that has just an x in it, so we just say we have 0 of those, minus 4. So if we place our x above the 0x, and if we multiply the first term times the last term, we get -4x squared. So now we're looking for two numbers that when multiplied together give us this -4x squared, but yet when added give us this 0x. So since this is a negative number, one of them is going to be positive and the other is going to be negative. And when you add them together you get 0. So positive 2x and negative 2x do the trick. So that's how I was able to look at x squared minus 4 and factor x squared minus 4 into x plus 2 times x minus 2. So now if I look at this equation, I have x plus 2, and over here I have another x plus 2. So using properties of exponents, I can say when you have x plus 2 times x plus 2, that's x plus 2 squared. So now I'm ready to solve this equation. I had to get it in factored form first in order to be able to do it. using the zero product theorem, I know that this factor of x plus 2 squared equals 0, or this x minus 2 equals 0. Well, if I take the square root of each side, that will get rid of this exponent of 2. And when you take the square root of 0, and even if we put the plus or minus in there, we've got square root of 0, 0. So this is just a one-step equation where you subtract 2 from both sides, and I get x is equal to negative 2. Well, this is a one-step equation where you just add 2 to each side, and I get the x is equal to 2. So for this problem that they gave me originally, I have 2 solutions. Alright. In our very last one here, we have 3 terms. And when I look, I don't see anything number that divides every term, so I have no greatest common factor. When I see 3 terms, the technique I think of is the x method. But will the x method work here? Well, it's set up for 3 terms. It's in descending order, 4, 2, and the constant. And this 4, if I take half of 4, I have 2. And that's important. If this was an 11x to the first power, or an 11x to the third power, I would have been out of luck. The x method would not work. We have to have the degree of the middle term has to be half of the degree of that leading term. Alright, so let's place our x over here. And I'm always afraid when I place my x that if I draw my x through my minus sign, that I might accidentally later on read that as plus. So be careful when you're placing your x that you don't cross over and turn a minus sign into a plus sign. That's just something that you're going to have to pay attention to and not do. The first term times the last term is negative 12x to the fourth. Now we're looking for 2 values when multiplied together give us this top value, but when added give us this bottom value. So I think that a positive 1x squared and a negative 12x squared do the trick, because the positive 1 times the negative 12 gets me that negative 12, and x squared times x squared gets me that x to the fourth. And when you add these together, you get the negative 11x squared. So we got exactly what we wanted. Now this leading coefficient is not 1, so I would be smart to continue this using a table. And like I mentioned before, in the x method, we enter information into our table along the diagonals, not going from left to right. So this 3x to the fourth, I place it up here, and the negative 4. Now technically along that diagonal those are interchangeable, but we just commonly put that the one with the biggest degree, the leading coefficient there, the leading term, we put it in that first box. Now along the other diagonal, we put the information from our x, and it doesn't matter again. I can put the 1x squared here or the 1x squared there. It doesn't matter on the diagonal, but it does have to be along a diagonal. So there's the body of my table that I'm going to help use to finish factoring this problem. If I look across here with this negative sign, and note these numbers are prime with respect to each other, I'm just going to put a positive 1. When I look here with a negative sign and a negative sign, I see that a negative is common to both. 4 is common to both, so we write negative 4. Now this one didn't have a variable and this one did, but they're not. I can't write a variable down because it's not in both terms. When I look at positive 1 times the negative 4 is negative 4, so I don't have anything that's inconsistent. I don't have any contradictions within my table. When I look across here, both of these numbers are divisible by 3, and both of them contain 2 factors of x, and we write that as x squared. So when I look at this up and down, this vertically, the 3 and the 1, we don't have a number in common, but with the variable x to the fourth and x squared, both of them had a factor of x squared. So when we multiply this together, the 3x squared times the 1x squared does give us 3x to the fourth because you add the exponents. And the positive 3x squared times the negative 4 does give us the negative 12x squared. And the 1 times the 1x squared, there's no contradictions in my table, so I'm ready to come down here and have this in factored form. So instead of writing this trinomial, I know I can replace it with 3x squared plus 1 and x squared minus 4. So just as before, I can continue factor. You want to factor this completely. When we look at x squared minus 4, was that the one that we did? Yeah, x squared minus 4, we saw that using that x method that we had x plus 2 and x minus 2. And whenever you have this difference of squares, there's a formula that hopefully you know that a squared minus b squared is a plus b times a minus b. So if you recognize how to use the formula, or if you look on your quiz or your test and maybe in a previous problem you've already done that work, that that x squared minus 4 factors. So we have 3x squared plus 1 times x plus 2 times x minus 2. So now with this zero product theorem, we have 3x squared plus 1. This factor could be 0, or that x plus 2 is equal to 0, or that x minus 2 is equal to 0. So over here, if we subtract 1 from each side, and if we divide both sides by 3, x squared equals negative 1/3, we stop and think, well, wait a minute. X squared means x times x. You're taking a number and you're multiplying it by itself. So if we had some negative number, negative times negative would be positive. And if we had a positive number and you multiply it by itself, you're going to get positive. So we say that this equation has no real solution. Now that's not our final answer, but with respect to this factor, this 3x squared plus 1 is not contributing towards us getting the 0. Now over here, if we subtract negative 2 from each side, we get, I didn't subtract 2, we get x equals negative 2, and if I add 2 to both sides, 0 plus 2 is 2. These are the two answers that we get on problem number 5. So hey, I'm going to give you a hard copy solution of this, and use this to study for our next quiz, and I'll talk to you later. Bye.